Hello, did you ever wondered something about database system architecture? Well, for today's video, we will be talking about the layer model and its evolution. I am Jerry Caliagas Navarez. You are in the right track. Welcome to Database Management Systems. Before anything else, let's define first what is database system architecture. So now let's begin. Since we'll be talking about the evolution, kind of like talking about when it started and how it develops. More than 2 decades ago, database researchers faced up to the questions of how to design a data-independent database, or database managed systems, or DBMS. That is a DBMS which offers an application programming interface, or API, to the user and whose architecture is open for permanent evolution. For this purpose, an architectural model based on the success of data abstraction steps of record-oriented data is proposed as kind of standard, later refined to a 5-layer hierarchical database model. As we experienced during the last decades, DBMS have lifetime less than 20 or even less than 30 years. In that time, system evolution requirements were abundant. Growing information demand led to enhanced standards with new objects, types, constraints, etc. These ideas of structured programming and information hiding were cornerstones guiding the way of development. The architectural description embodies the major steps of dynamic abstraction from different layers. So there are 5 layers of hierarchical DBMS, and that's what we're talking about in this video. Right, first, the bottom layer. This called file management operates on the bit pattern stored on some external non-volatile storage device, often in collaboration with the operating system's file management. This layer copes with the physical characteristic of each of the storage device. Propagation control, as the next higher layer, introduces different types of a linear address space and mapped into physical blocks, which are in turn stored on external devices. The file management, the strict distinctions between pages and blocks offers additional degrees of pages. For example, a page can be stored in different blocks during its lifetime. The database thereby enabling atomic propagation schemes, supporting failure recovery based on logical logging to effectively reduce the physical input and output. That this layer provides a large DB buffer which acts as page-oriented interface with fixed and fixed operations to the functions of the database currently resident in memory. Number 3, the record and access path management implements mapping functions much more complicated than those provided by the 2 subordinate layers. For performance reasons, the partitioning of data into segments and pages is still visible at this layer. It has to provide clustering facilities and maintain all physical objects representations, that is, data records, fields, etc., as well as access path structures. It typically offers a variety of access paths of different types to the navigational access layer, especially with the clustering options and the provisions of flexibility usable access that are tailored to the anticipated workloads. This layer plays a key role for the entire DBMS performance. Number 4, the navigational access layer maps physical objects to their logical representations and vice versa. At this interface level of abstraction, objects auxiliary mapping data the user of the modules at the next higher layer navigates through hierarchy or network of logical records or along logical access paths using scans of various types. A special ability is to dynamically order or sort sets of records to support higher operations such as sort, merge, joins. Finally, the non-procedural access layer provides logical data structures such as tables and views. With declarative operations of a non-procedural interface to this database. At the API, it provides an access path independent data with descriptive languages. Example, SQL. Each layer needs a number of auxiliary data structures for mapping higher level objects for more elementary ones. DBMS architecture is still valid. An enormous evolution or progress has been made during the last 2 decades concerning functionality, performance, and scalability. The fact that all these enhancements and changes could be adopted by the proposed architecture is a DBMS model. Alright, we show that the 5-layer hierarchical model proposed more than 20 years ago was able to accommodate all the extensions and optimizations for the originally established paradigm. Even new data management scenarios, incorporating the processing invariance of our 5-layer model could be well embraced by architectural variants of it. And that would be all for our database system architecture covering the layer model and its evolution. I am Jerry Caliaga Tavares. Thank you for watching.